right, let's go ahead and get started on section 6.2, division and fractions and division with remainders. You have numbers 1, 3, 7, 9, and 12 to turn in, and we'll take a look at some of the other problems. Similar, but not the same. All right, so using our definition of fractions, the idea of measuring one strip by another strip and how many groups division, explain why 5 divided by 8 is 5/8 and 8 divided by 5 is 8/5. Your explanation should be general in the sense that you could see why the equations would still be true if other numbers were to replace 5 and 8. Okay. And they asked us to use strips of paper, right? So let's see. Oh. Okay, so let's use strips, definition of fractions, and how many groups division to explain each of these scenarios. So we've got how many 8s are in a 5. So let's draw one strip with 8 parts. And another strip with 5 parts. 1, 2, 3, 4, 5. Right underneath so that they're the same size. And for 5 divided by 8, then we're saying how many of the first strip does it take to make the second strip? Where these are the strips of paper, right? And we can, let me label this first and second for myself. The other direction's easier because the smaller amount will be on the first, but they asked us about the 5 divided by 8 first, so we'll do this one first. And so those are our strips of paper. And then we also have the how many groups perspective. So we're saying how many of the first strip does it take to make the second strip? 5 divided by 8. 5 divided by 8. So that's our how many groups perspective. And then the last bit is to discuss why we're getting the result of 5/8. And in the definition of fractions, this is 5 pieces where the pieces are of size 1/8. Okay. Now, if we go back to our drawing and focus on the fact that we're saying how many of the first strip does it take to make the second strip, we cut the first strip into 8s. And then from that, we constructed the second strip, but we constructed it out of 8s, right? So I'm going to go in with a different color. And these have the value of 1/8. And it takes 5 of them to make the second strip. So we have 5 pieces, and each of the pieces are of size 1/8. So we've used strips, we've used groups, and we've used fractions to express why 5 divided by 8 is 5/8. Okay, now if we want to reverse the question, as they're asking us to do in 8 divided by 5, we can draw these exact strips if you want, or we can draw it in reverse so that the first strip is now 5 long and the second strip is still the 8, but let's draw a second one. Let's flip it to the first one is the 5 and the second one is the 8. It's always easier to draw 8. So I'm going to draw that one first. I don't know if I did it very well, but I think not. A small piece there. Okay, and then we've got 2, 3, 4, 5. Okay, so now when we ask how many of the first strip does it take to make the second strip, we're asking how many of the 5 strip of 5 does it take to make the strip of 8? This is our 8 divided by 5, the second part of the question here. And this time around, we're seeing a result of 8 pieces of size 1/5, because we took the original strip 1, it's 5 pieces in length, but that's our whole. And so each of these have a value of 1/5. And then we took 8 of those 1/5. Let me do that in the different color. We took 8 of these pieces, each of size 1/5, to build this second strip. So we're getting 8 pieces, and each is of size 1/5. So we've got part A and arbitrarily part B, but they both share the words. How many of the first strip does it take to make the second strip? I couldn't find anything in the chapter. They used circles every time. They used pizza and circle charts. So definitely doing it by strips was a little bit of a challenge, but there are examples in the class activities where they do this exact process. So that's where I looked, was in the class activities. Okay, that was division and fractions. And we used the how many groups perspective. This time we're looking at different styles of remainders. So division and remainders, and possibly the how many units in one group style of division. So here in number 4, we have the pounds and ounces problem. Given that 1 pound is 16 ounces, how many pounds are 50 ounces? Write and explain a division equation for the pounds and ounces problem, and determine if the problem is a how many groups or how many units in one group problem. Okay, so we use our definition of multiplication as a guide to help us answer and set up our division. We are told that we have 16 ounces per pound. We are also told that we have 50 ounces. We are looking for the number of pounds. So this is a how many groups perspective. And the equation is 50 divided by 16. So that's our part A. Part B reads, interpret the whole number with remainder answer to your division equation in part A in terms of pounds and ounces, in terms of the pounds and ounces problem. In terms of the context, what does the whole number part of the answer mean? And what does the remainder mean? Okay, so for part B, we are looking at having to do the division. So 50 divided by 16. I think we can get 3 out of there. So 3 groups of 16. 3 times 6 is 18. Carry the 1. 3 times 1 is 3, plus the 1 is 48. Then we have this remainder 2. So they want to know, what does the 3 mean? And what does the 2 mean? So saying we have 3 remainder 2, what are we saying? Pounds, ounces, what's going on here, right? So 16 ounces per pound was what we were taking out, and we were trying to find how many pounds that we could make through that repeated subtraction, right? And so we've got 3 pounds, but then we have a leftover amount of ounces. And sometimes we'll even annotate the equation over here and say ounces per pound, just to see it. right? And these are ounces. So if you have an amount of ounces, then all you can subtract from it is ounces. And therefore, all that's remaining is ounces as well. And then again, your top value was your groups. And we already identified that the 2 was our ounces. So the whole number representation of this answer is 3 pounds and 2 ounces. Now, part C wants us to interpret the mixed number answer to your division equation in part A. In terms of the pounds and ounces problem, in terms of the context, what does the whole number part of the answer mean? And what does the fraction part of the answer mean? So for part C, they're saying when we write the answer as 3 2/16 instead of 3 remainder 2, then what are we saying? What is the 3 and what is the 2/16, right? We can reduce this to 1/8 if you like, but then you're saying, again, give yourself the form 3 blank and 1/8 blank, right? What are these? So when we put the 2 ounces over the 16 ounces per pound, we're getting a portion of a pound, right? And so here we've got 3 pounds, same as the last time, but the 1/8 is 1/8 of a pound. So the answers have different units when we express them. And that's what they're asking us. And you have to form questions that produce these different style of answers, right? So we did 50 divided by 16 twice, but we represented the answer in 2 different ways. One in pounds and ounces, one in just pounds. Okay, let's take a look at number 10. For each of the following problems that follow, oh, I think I said the wrong word, but whatever. For each of the problems that follow, write the corresponding numerical division problem and solve the problem. Determine the best form or forms of the answer, meaning a mixed number, a decimal, a whole number with remainder, or a whole number that is not equal to the solution of the numerical division problem. Briefly explain your answers. So for A, we have, for purposes of maintenance, a 58-mile stretch of road will be divided into 3 equal parts. How many miles of road are in each part? So we have 58 divided by 3. Let's see what we get from that. So 19, remainder 1, but we can split the road into thirds, right? So for maintenance purposes, we would want 19 1/3 miles dedicated to each part. That is a how many in one group perspective. And we don't want to leave out any of the road. So, okay, let's take a look at B. For purposes of maintenance, a 58-mile stretch of road will be divided into sections of 15 miles. Each section of 15 miles will be the responsibility of a particular road crew. How many road crews are needed? So we have a 58 divided by 3 situation. And, oh wait, sorry. I just wrote down the same thing I had before. A 15 divided by, sorry, a 58 divided by 8. Okay, now it's not even funny. 58 divided by 15. Okay, my brain's just getting excited because this is one of those examples of a whole number that's not equal to the solution. So let's check it out, right? So we can fit 3 sections in there, but not quite 4, right? So let's see, 3. And really, we're finding crew members, not sections, but that's 45. And then we have left over 13, right? So here we have 3 and 13/15 of a crew member needed. And so we're going to, instead of using 3 remainder 13 or 3 with 13/15, we're going to say that we need 4 crew members or road crews, I guess is how they worded it. We're still going to send a crew out to clean that 13/15 of a road or maintain it or whatever is necessary. So that's always an exciting one to see. Okay, let's look at C. You have 75 pencils to give out to a class of 23 students who insist on fair distribution. How many pencils will each child get? So we have a 75 divided by 23 situation. When we divide 25 by the 75 by the 23 students, we're going to give each kid 3 pencils, right? That's going to take 69 pencils out of the pile. Then we're going to have 6 pencils left over. So here we are going to use 3 remainder 6 because we're going to give each child 3 pencils and we're going to have 6 pencils left over, right? Let's see. Because we can't give out another 23 pencils. So that's an interesting one because it's a how many in each group perspective. But we're not going to put the extra 6 pencils in any of the groups because we just don't have enough. So 3 pencils per kid. So 3 pencils per group and 6 pencils left over. because they insist on fairness. And now 6 kids are like, well, I don't really care if you're fair, right? Okay, D, you have 7 packs of chips and share equally among 4 hungry people. How many packs of chips will each person get? Okay, so this time we have 7 bags of chips, and we're going to split it amongst 4 people. And we have a 7 divided by 4 situation. We don't quite get 2 bags apiece, right? We've got 1 bag, and we've got, let's see, let me write these out. This is our packs of chips. Okay, and then this is our people. We have 1 pack of chip we can give to each person with 1 pack of chip, sorry, 3 packs of chips left over. So 1 pack of chips per person, that's 4. And 3 packs left over, that makes 7. Okay. Sometimes it's a little tricky. Okay, so this time around, we are going to give each individual 1 3/4 packages of chips. So on D, we chose the mixed number. On C, we picked the whole number with remainder. On B, we picked the whole number that's not equal to the solution. And on A, we picked the whole number, oh no, the mixed number again. So none of those were appropriate for decimals, although if you were forced to make one of them decimals, probably the measurement in red, but the book just has these as potentials. They don't have an actual decimal problem here for me that I can see. If you had to write the questions yourself, you could turn it into a money situation so that you did have a reason to have decimals as an answer. And then you can see all the potential ways the remainder would work. So let's see. Okay, so we've seen division and fractions, and we've seen division with remainders. Now, here's a little kind of a fun one, right? And we can use the remainder to find answers when there's certain patterns. So in number 11, we have explain how to solve the next problems with division, assuming that today is Friday. Which interpretation of division do you use? Okay, so assuming today is Friday, let's think this out a little, right? So if we had a day 7 days from today, right, that would be another Friday. So 1, 2, 3, 4, 5, 6, 7, right? if this is a Friday, then 7 days from now will be a Friday, right? And if we had 8 days from now, that would be a Monday. If we had 9 days, that would be a Tuesday, right? 10 days, that would be a Thursday, for example. Oh, a Thursday. Sorry about that. It's the little things. Okay, so, oh my goodness gracious. Okay, let me restart this. We'll leave Friday where it's at, but then refill the days in more appropriately. After Friday is not Monday, you can see why I think the weekends don't last because they don't exist in my brain. Let's see, but after Friday is Saturday, then Sunday, then Monday, then Tuesday, Wednesday, Thursday, then we wrap back to a Friday. Okay, we're on board again. Phew. Okay, now, if we have days that are 11 days away, right? Then we are on a Tuesday, 12 days away will be a Wednesday, 13 days away will be a Thursday, and then 14 days away will be a Friday again. So 14 days away. Okay, now let's take a look at this second row here and see what we have, right? If we divide 8 by 7, we get 1 remainder 1. If we divide 9 by 7, we get 1 remainder 2. If we divide 10 by 7, we get 1 remainder 3. That remainder tells us what day of the week we're on. So if we get a remainder 1, we're on a Sunday. If we get a remainder 2, oh, I do not know my days of the week. If we get a remainder 1, we're on a Saturday. If we get a remainder 2, we're on a Sunday. If we get a remainder 3, we are on a Monday. Okay. And so on. Now let's look at the end, right? So dot, dot, dot. Now 7 into 13, we have 1 remainder 6. And then 7 into 14, we have a remainder 0. So to get back to Friday, that's actually our starting point of remainder 0. So you can start the drawing on a Friday and then count forward with your remainders. But I just am going to leave it how we have it sitting. Okay, now that we have our little counting, table in place, we can look at what day of the week will it be 50 days from today, 60 days from today. We can, however, talk about what are we doing here? And we are definitely grouping. So we're finding the number of groups. We're talking about how many weeks are there and then the remainder, right? Because in 8 days, you have 1 week, remainder 1 day. So we're finding the how many groups perspective. Okay, now let's take a look. We've got 50 divided by 7. That's a 7, remainder 1. Remainder 1 gives us a Saturday. For B, we have 60 divided by 7, right? 8 times 7 is 56. So we have a remainder 4. Remainder 4 puts us on a Tuesday. Just double checking. Okay, check, check. All right, doing good so far. Okay, now C, we're gonna take 91 divided by 7. Let's see, we can get into the first number with remainder 2. Bring down your 1. Then we can make 3 groups of 7 out of that. 13 weeks is 91 days, is what we're saying. And we have a remainder of 0. So in fact, 91 days from today as a Friday will be a Friday. And then 365 days from now, you would think it would be a Friday, right? But let's see. So we have 36 divided by 7, which is 5. And then remainder 1, bring down the 5. We can make 2 groups out of 15 for a remainder 1. So we're getting here a Saturday. Thank you all for being here.